on the last workshop where I taught you the basics and fundamentals of React Native, or at least, I mean, the ones who joined last time. So let's start off with a basic introduction to Firebase. Can you all see the presentation? PowerPoint? Okay, so we know that every web application, it's composed of mainly two parts. The front end, which is on the client side, and we build it using Angular or React Native, and the back end, which is on the server side, and we usually build it with frameworks like Node.js or ASP.NET, and many, many more. And the front end talks with the back end. It sends data to it using HTTP services, which are known as CRUD, or in other words, create, read, update, and delete. And the back end, at the same time, also talks with our database in the web application, if we have one, such as SQL Server, Mongo, and Raven, as we see on the screen. But as a front-end developer, or in other words, as a developer who's working with the React Native, for example, we don't need to worry about working on the back-end part, on the server side of our application, because that isn't our part. We only care about what the client experiences. So that's where Firebase shines. With Firebase, you can build a backend in less than a minute. It's a framework that provides a fast and scalable and real-time database in the cloud for you to use. On top of that, you can use authentication with it, and not only email and password-based authentication, you can even use it to sign in with Google and other sign-in services. In addition to that, you have cloud messaging, so you can build a chat box for your application where users can chat with each other or send messages via Firebase, in addition to storage and analytics. What's good about Firebase is that it provides libraries for different languages and for different platforms such as iOS, Android, JS, and C++. What that means is, if today you're building an application using React Native and you're linking it to Firebase, which is your backend, in React Native, you'd be using JavaScript, for example, but let's say tomorrow you want to use another application in Angular, which uses C++. So, and if you want to link it to the same database, the same backend, all you have to do is just create or build that client app using Angular and link it to Firebase using libraries provided by Firebase and C++. So now you might be wondering that all these services, such as database on the cloud, authentication, user authentication, cloud messaging, that they must come with some like hefty price tag. But however, fortunately, that's not the case. You start off with a free plan. You can use databases, you can use authentication and all that. And whenever you want to expand your application, you can pay to go. For example, you can add like more advanced features in case you're building a more complex app, and you can add more storage to your database in the cloud. So now I'm going to switch over to talk about Nosql Database, and that's what databases in Firebase are examples of. So for those of you who are familiar with SQL, for example, or in other words, traditional relational databases, your data is put in tables in a database, and each table has a specific schema. What that means is, if you want to insert data into your table, you have a specific schema for that. So you only have specific fields or columns, as you can see on the screen on this users table, and each field can be a specific data type. So for example, if you define that age should be an integer, a user can't input a value like old enough, which is a string. In that case, that wouldn't work with SQL. So fields should always be of the data type that you've specified in the schema. And sometimes you might have different tables for different objects, because as you see, if you have a specific schema for a table, that means each table can take a specific type of object. So for example, in users, objects can only have a primary key, a username key, an age key, a login date key, and is admin key. So an object in the users table can't have other keys. So if you want to have project objects, you can't store them in your users table, because you can't have those keys that you need to define each project. So for that reason, you'd have to create another table for your project and define another schema for that table with its own fields and their own data types. But sometimes you want to link different objects of different data types or of different types, in this case, projects and users. You'd want to link them together. And how you do that in SQL or in relational databases, to the projects table, for instance, as you can see on the screen or on the slide, you'd add another field, which in this case is a foreign key. And as you can see, the foreign keys are equal to the primary key in the users table to show that this is related to this. For example, if we were building a restaurant review application, you'd have three tables: restaurants, reviews, and users. And you can like sort of see how they're all linked together with these primary keys and foreign keys. And that's how you'd get data for like a specific query. So for example, let's say you're using this app and you wanted to get the reviews for a restaurant called Todd's Tacos. If you wanted to get the reviews, you'd have to search or query the reviews table for all reviews that have as a foreign key the ID of the restaurant in the restaurant's table. And you do the same for users to know you'd have the user's foreign key in the review object, and you'd use that to query the users table for a user with that ID. And that way you can join data and get reviews with, for example, user's name and profile picture and show it to your user. And what's good about SQL is that it does that for you with a relatively straightforward select statement where you can just join all these IDs and foreign IDs and get the data, the relevant data that you need. Now, if we move to NoSQL databases, you don't have this concept of tables or of schemas. So databases or NoSQL databases are schemaless. What's good about that is that if you want to add fields to a specific, let's say, object or like object key, in this case, restaurants. So you have an object that contains your restaurants, and each entry in this restaurants object will have specific fields. In the case of SQL, each entry would need to have the same exact fields with the same exact data types. In this case, these fields don't have to be the same. So for example, in the same restaurants object in your database, if you notice, you could add like a noise level key for one entry, a tandem jumps key for another entry, and a tattoo style key for a third entry. And you can do all that without causing your database to freak out or give an error. Now, you might think, since you don't have tables and you don't have this concept of keys or foreign keys, so you can only have objects, and each like object structure has its keys. So the bad thing is that you can't do a join query where you can join data from different objects, or let's say tables. They're not tables, but let's say like a group of objects. In this case, what I mean is reviews and the restaurants. What you do for that is that you could, for example, give a restaurant and the user key for each review. And so you'd first query the restaurants for the specific restaurant that you want. So you'd have that like value, the name of the restaurant. And then you'd have to query the reviews again for all the reviews that have as a key that restaurant's name or ID in this case. So in this case, you're doing two queries instead of one. But now that's not a big of a problem, because usually in an application, you'd first see like the list of restaurants, and then the user, when he'd select, so that would be the first query, getting all the restaurants. And when the user like presses on one restaurant, you do, in this case, the second query. So both queries are separated in time, so the user won't feel like he's waiting too much, because they're like separate in time, so he doesn't feel like there's lag or something. But let's say now that you don't just want to show each review, you also want to show the user who gave that review. So in this case, you might think that, oh, I could do the same for each review. I could give a user key. But the problem here arises is that if you want to get each user's details for each review or each reviewer's details using this method, you'd not just have to query the reviews object, because if you query the reviews object for each, when you you iterate over this first review, let's say this is the restaurant that you want to get reviews for. So you'd see this user key. You'd have to make a separate query when you're done for this table or for this object to find the user with that key and then get his data or her data. Then you'd have to do the same thing for each user. So you'd have multiple queries all or after each other. So the user who's using your app would have to wait a lot of time. So what you could do to solve this is that instead of having user keys that refer to entries somewhere else, you could duplicate the relevant user's data. So for example, if you have a review and you want to get details about the user, you could duplicate his name and his profile picture and place that same data in each review entry. So although you'd be duplicating data, it doesn't seem that bad because first of all, the data that you're duplicating isn't that large. And second of all, the reads, or in other words, getting data from this database would be much more than the writes, adding data to this database. Because imagine some application like Facebook, you're reading data or you're getting data from Facebook's database, like you could say like 1,000,000 times more than you're writing data to Facebook. Like you're adding a comment, you're changing your profile picture. So although you might think that errors might arise, whereby someday the user changes his profile picture, so you'd have to create some logic to update all of these, that wouldn't be that much of a problem, since as I mentioned, the writes are much less than the reads. So this is one good aspect of NoSQL databases, in which provides fast querying, although you're duplicating data, but it's not that much data. So now I'll show you how to create your first Firebase project. As I mentioned, you can do it in basically in a few minutes. So you have your front end project, which we created last time in the last workshop, which is this over here, which was our course review application. And at that time, it was only a front end application. It only consisted of front end, which was what the user sees. Like we weren't talking to some back end and behind the scenes. So now let's say you want to store the reviews not on the user's phone, but instead on the cloud. And you would want different users of your application to see each other's reviews. So you could do that using a backend. So if you want to create a backend using Firebase, it's as simple as this. Now you see here, I have a course review app, which is for this. I made it before the workshop just to test it. So first of all, you have to go to the site. I'll paste it, copy paste it in the chat, console.firebase.google.com. Okay. So you press this add project. It asks you for a name. You can put anything. It's just its name on the Firebase console. So in this case, let's say workshop 2. Continue. It asks if you want to add Google Analytics. We don't care about this for now since it's a basic workshop. So I'll just not add it. And create project. You just wait a bit for this to finish. And just like that, your new project is created. So it should appear now on my console. So this is now your backend ready to use. So of course, initially it's not linked to our application yet. How you can link it is as simple as this. You have these options here to add Firebase to your application. You could add it to iOS, as I mentioned, Android, web, in other words, JavaScript, or even Unity. Now we're using React Native, which uses JavaScript, and React, I mean, it's like for the web. So you use this option. You add a nickname, can be anything. So workshop 2, register app, add Firebase SDK. So this is like the configuration that you need to include in your React Native application, in this case, since we're using React Native, so that it would be linked to the Firebase backend. So I'll copy this from somewhere else. So you just continue to console, and now it's set up. For now, let's add a database. So databases in Firebase, there are basically two. You have Cloud Firestore, and you have real-time database. Real-time database was Firebase's original database. So there, at the beginning, there was only a real-time database. And as you can see on the screen, it's an efficient, low latency solution for mobile apps that requires synced states across clients in real time. So what that means is, let's say, for instance, you have an application where you see a map with like people's locations. So the data on your phone on the map would be updating every second as a person moves around, let's say. So if let's say on this application, you can see other people's locations who are using this app. There are many known applications like this. But I mean, the idea is understood. So in an application like this, you'd need to get data every second, or even less than a second. So whenever his position changes, some user's position changes, you'd want to see that updated on your map without doing anything. So since you'd need to use like async states, whereby all the users would be seeing the same map at the exact same time, real-time database is recommended in this case. However, with the new introduced database, Cloud Firestore, it builds on the successes of the real-time database with a new, more intuitive data model. Cloud Firestore also features richer, faster queries and scales further than the real-time database. So you could use this, as I've just said, for faster queries and scales. So you could get data faster if you had to join multiple data together. So now let's get back to creating or to linking Firebase to our app. In this case, we'll be using real-time database, although it doesn't really matter since it's a relatively simple app with not that much talking to the database, since we'll just be getting the reviews and we'll be writing reviews. So there isn't much complexity in our application for now. So I just press this here. I go to real-time database on the left menu and create database. Next. And you can start in locked mode, which is usually what the database would be in when it would be published, since you don't want your database to be public to anyone. And they could read from it and write to it. But for now, let's just start in test mode, since we don't really care. And we're testing the database. So this is basically your database. For those of you who are familiar with JSON, this is like basically like analog, or it's inspired by JSON. It's like objects. So in this object, in your database object, this is like the parent key, and its value is initially null. So you don't have anything in this database. So we'd want, for example, as we grow our database, to add keys. For example, let's say in the case of the restaurant application, you'd have keys like users, restaurants, reviews. Inside this parent object or this parent key, then those keys themselves would be objects, their values would be objects, where each object would have keys in that are related to each restaurant. So like each key would be an ID for each restaurant with its own data. So now, as we'll be building this application, you'll get a better sense of what I'm talking about. So now we have a real-time database ready to be used, but we still haven't linked it to our front end or to our React Native application. So to add the configuration, as I've mentioned, you just go to this gear over here, project settings. You scroll down and config. And this is it. This is the config object that you need to add to your front end. So you just copy it, just copy paste it. I'll add back to my application. I'll delete this. I'll create a new one. Or let's say I'll delete this, yeah. Or I could just talk about it. I mean, it doesn't really matter. So first of all, you have to install Firebase, the Firebase library on your platform. In this case, we're using React Native. So you do something like npm install Firebase, this library over here in the terminal. I've already installed it, not to waste time. You import the Firebase object or API from Firebase. You then add over here your config. This is the config for the old project, which you've seen on my console. So I'll add the new config, this one. And to create, like to initialize your application or to link Firebase to your front-end application, what you do is Firebase, which is basically this, what you imported here, you call the method initialize app, and you pass to it the configuration object that consists of all these keys and like cryptic values. And we'd want to use the return value of this for our database and authentication needs. So what I'm doing here is just I'm exporting that variable that I've just created over here to be used in other files or other screens, I mean, in our front-end application. So now we have this file I'm done with. Let me just get rid of this. Okay. So let me now show the application. Okay. So this was basically where we left off in the past workshop. So currently we're storing all the reviews that we, add to this application. For example, this one, then anything. We're storing it in the local storage of the phone. So other users who've installed this application on their phone can't see your reviews because you're adding them to your own storage, to your local storage. So when they install the app for the first time, they'd start out with an empty database, with an empty reviews. So no, they wouldn't see any reviews for any application. So to start seeing reviews, they'd have to add their own reviews. And the only way they could see other people's reviews is if those people took their phone and added a review using their installed application on their phone. So of course we wouldn't want to do that for, a real world application. We'd want, it to be connected between users, of course. So in our past version of the code, the way we were storing the data and adding the way we were getting the reviews and adding the reviews was using async storage, which, as in the past workshop was mentioned, it's an API. It's a core API of React Native that's given to you to store things and get things from your local storage. So what I was doing here was I would import it first of all from here, that API or that object. If I wanted to get an item, I would have to call the method getItem. I'd pass to it the key of the item. So as you can see, the data is also stored like key value pairs. So for each key, you have a value. So, since it's a basic application, each key would naturally be the name of the course. And we have a course variable that we get up here. which is equal to the current course. So we pass that to get item, and then this dot then just means that when this data is returned, because now I wouldn't like to get into this since it's a more advanced topic. This is an asynchronous function. What that means is that when you call this method, when your program runs and this method is called, the value isn't returned immediately. What that means is if you're doing something with this value, so let's say you're setting this to some variable like this, and then down here, let's say you're console.logging it simply. Wait, my bad. Const and my var. Okay, that way. You're storing the return value of this, and over here, you're console.logging that value. Now we can't see this. I mean, I just wrote it to explain what I was talking about. If you try to get that data that way, you're doing this synchronously when actually this is asynchronous. So to start from scratch, what this means is you're trying to get a value from here, but that value isn't returned immediately and isn't stored immediately in my var. This has to talk with outside APIs. And then when it gets the value from the API, or when the API returns the value, only then does it get stored in my var. But your application, since this is asynchronous, synchronous means like harmonious, like happening after each other. So when you call this, you're telling your application, go get me this value. The program doesn't just stop there and freeze and wait for this value to be returned. It continues to the second line and executes it. So when you're executing this value, this line, you're console.logging my var. At this point in time, you still don't have the returned value. So my var doesn't contain anything. So it would, essentially be null. There wouldn't be anything there. So in order to treat asynchronous functions or deal with them, what you do is you'd provide a callback. A callback basically is a function that you provide to an asynchronous function. And what it does is this callback should take as input the returned value from the asynchronous function. And only when the value is returned from the asynchronous function, the callback gets executed with that returned value. So this is like a way this is how you deal with asynchronous functions or values that are returned by asynchronous functions. If you want to do something with them, when the value is actually there, you can't write it down as I just did. You have to provide a callback function, which will do something with it once the value is returned, like after a short period of time. So this is like one way to do callbacks in JavaScript. So after the function, which is supposed to return the value, you'd add to it .then, and this is basically the callback that I was just talking about. So this callback, it's supposed to take as input a variable called value, which in this case is equal to this when it's returned. And this is the key course. So its value would be an array containing all the reviews of that course. So if its value was initially null, if we haven't like added any reviews for that course on the local storage, which is the case when you first install this application, its value is going to be null. I mean, that key value pair isn't going to exist. So we want to have a way to deal with that. So what we do is we check if value is null, set reviews, which was our variable here, or no, wait. Yeah, here. We set it to an empty array. Else, if it's not null, so we actually have some reviews, we just set reviews to the returned value. And we'd use async storage to add reviews the same way over here. So don't be worried, if you don't understand everything else. I'm just focusing on the database part. So this is how you would add data to your local storage. You do async storage dot set item in this case instead of get item, since you want to add data. You'd pass in the key, which in this case is our course. And the second parameter would be its value that you want to add in the local storage, which in this case is basically what this means is an array containing all the values inside of reviews. This three dot means copy all the elements in the reviews array and add them to this new array. And we're adding to it one more element, which in this case is the my review variable. And that's how we would be storing it in our local storage. So in case we close our app like this, let's say I write anything here, there's this new review over here. If I close it, it's still there because it's stored in the local storage. So you don't start from scratch with empty reviews. So let's say now we want to store this data not on the local storage, but on the cloud in our Firebase storage, in our Firebase database. So we've already created this Firebase object over here, which is basically our app. And one sec. Okay, never mind. Log in. Okay. So the way you'd use the database, your database on Firebase, is first of all, you have to import that Firebase object which you've created in that file, fb.config.js, like this. Import the name, which was fb. Yep. You say from, and you pass in the file name, fb.config. And this is, now you have it in this file. So you can use this object over here. So the way you get the database object is you do this, or the database API, const, let's say db, database equals fb dot, now you see all these methods over here. So analytics, authentication, database, delete, firestore, which is the other database. Database here refers to a real-time database, and we have a real-time database. So we'd use that, and you call it, and now you have your database object over here, which you can use to add and get data from your database on Firebase. So now let's replace this with Firebase methods. So we only used async storage, or I mean, we used our database in two parts. When we were getting all the reviews the first time, when we opened the screen, and when we were adding a new review to our reviews array. So let's comment this out and write its, I mean, its synonym, let's say, in Firebase terms. So what you do is, using this new DB object, you do dot reference. So what you pass to this is a string referring to the key in your database. And how you do this is you treat the keys like routes. So the parent route, of course, is just a slash. So that means the parent route or the parent key, which is essentially this. So slash refers to this, and we'd get from this route the value of this key, which in this case is null, since we don't have any data there. So, but we wouldn't want like to get all the data in our database, because that would be getting too much unnecessary data. So the query would take longer. If you'd want to get all the data, that means all the reviews for each and every course, you'd want to get all of them using this method over here. But since we already know which course we want to get reviews for, that isn't necessary. So we can add to this like a route. So like you'd write on your computer, for example, users, Steven, like this, for example. This here refers to the parent key. This would be a key inside that parent keys value object. So if I can draw it out for you here, but so your database would be something like this. So const my DB equals this slash over here refers to this. So this is your slash with its keys. Users would be somewhere inside, and it would be another object. Stephen would be inside users, and it could be any value. It could be a string, it could be a number, it could be even another object where you'd want to add another key, and thus if you'd want to access that key's value, you'd have to write it over here. For example, if I had age, to access age, you'd have to add it like this. So in this case, essentially, our database would have keys that refer to each course. So we could just say slash plus course. So, I mean, that's essentially in this case, math 101. But we don't know that's math 101 all the time since it's dynamic. Now you notice that this key doesn't exist in our database, but nevertheless, you can still try to get that key using db.ref. And what's good about Firebase is that if that key doesn't exist, your app won't crash, or I mean, there won't be an error. It would simply return null. So you can like do defensive programming over here, where you account for that case and do something in case it doesn't exist. So to continue, how you'd get that value, you do dot get, or no, wait. Now here you can use either on or once. What that means is if you do once, you'd get that value only one time and no other times. If you do on, you'd get that value the first time you call db.ref.on. And what's nice is that with .on, every time the value changes in the database, so let's say some user added another review, this would be called again. So automatically, whenever the database is updated, that would be called here again, and you'd see the review, I mean, immediately on your side. So now, although we're just using this application on one phone, in this case, the simulator, we won't be able to see this in action, but this is what happens. So you do on.on, you pass in a value. So you just have to memorize this. You don't need to understand it. And a callback. So again here, since you're calling data using your internet, that doesn't happen like immediately, like some basic synchronous function. This is asynchronous. So again, you have to wait for that data. So in order to do something with that data, you'd have to use a callback. You can't just set db.ref, assign it to some variable, and then use that variable, because that variable would be null, even if, I mean, the key isn't null. So I'll just call it snapshot here. You can, this is like the argument which you define when you're defining a function. And this is the body of the function. So what do I want to do with snapshot? So in order to get the value, snapshot isn't the value which is stored in your database. The value which is stored in your database is const, and let's say my val equals snapshot dot val. So now my val is equal to this key's value in our database. So now what were we doing in async storage once we had that value? We were checking if my val equals null, set reviews to an empty array. And that's the case at first when our database is empty. Else, if it isn't null, set reviews to my val, to that array of reviews. And this is basically it. Now you saw all the reviews disappeared. That's because we're not using async storage's database anymore. We're using Firebase's database. So there aren't any reviews over here. So we don't get any reviews. So now how about writing to this database. So this was where we were writing or adding reviews. So let me comment this out. It is basically this part over here. So how you write data in Firebase is, or at least in the real-time database, is this way. You do db.ref again. So you're specifying to which key do I want to add data or set its data. In this case, it's the course key. So what you do here is instead of saying .on, you say .set. And you simply pass in the new value. So the new value, according to here, was our current reviews. In addition to that, the new review, my review. And that's basically it. This is how you can write data to your database on the cloud, as simple as a one line. And we can account for an error, because usually with async storages, with asynchronous functions, I mean, you don't always get the value. Like for example, if your Wi-Fi is disconnected or something, there would be an error in addition to other kinds of errors. So the way we deal with errors in JavaScript is using .catch, and you pass to it a function that takes in an error variable, and you do something with it. Now, in a real-life application, you, for example, alert the error to the user, or according to what the error corresponds to, you'd show something to the user. For example, like, sorry, it didn't work out, try again. But we don't care about handling the errors for now, so we just print it to our console. Let me just make this code cleaner. Okay. So now we have the logic set up for writing to our database. So see what happens now when I add a new review. Let's say this course is amazing. Add review. It's added to our reviews variable inside our front end, or by doing this. And we're adding it to our database, but we can't see this over here. We don't know for sure that was added, because what we're seeing here is the reviews variable. So we aren't calling, I mean, the database again. But what you notice is, if you go over here, back to your database, on Firebase, console.firebase.google.com, you notice this new key has been added because you've set something to this key over here, to the setout, / math101. So this gets added, and it's equal to the value that you pass over here, this array, which contains all the previous reviews and the new review. In this case, the previous reviews were nothing, and the new review is this. This course is amazing. So that's what you get over here. If I extend this, you see this is an array. This corresponds, since it's still an object, you can't like technically have arrays. So the keys would be like the indices. So in this case, 0, and its values, this course is amazing. If I add another review, let me keep this open. Okay. Hi, add review. You see it automatically gets added to your database. So now whenever you enter this again and you're calling the data again, you get it. You see, you still get that. This course is amazing and high when you're getting data from this key in our database. So that's for the real-time database. We covered writing data and getting data. So now what about authentication? So as you've already noticed, our authentication is basically nothing. So you simply press login, signed in, and takes you to your main page. But of course, I mean, an app wouldn't be like that. So how you deal with authentication in Firebase is you go over to your Firebase console. You want to set up authentication. This is authentication. Get started. And these are all the ways that you can authenticate a user. You see, you can easily authenticate a user using Google, Play Games, Game Center, Facebook, Twitter, all these ways, with just simple methods provided to you by Firebase. So that's like the power of Firebase in a nutshell. So it simplifies the backend for the front-end developers. So in this case, let's use email password-based authentication. So let's enable it, first of all. This is email link, so without a password, we wouldn't want that. We want a password, so save. So now email password authentication is enabled in our Firebase project. So let's make use of this. So again, in our login screen, we'd import the Firebase object from this file. And now instead of getting the database object, as I did const db, we'd get the authentication object. So const auth equals fb.auth. So now these are the functions that I have up for login and sign up. So when this gets pressed, this gets executed. So we're navigating to the new page instantaneously. Okay. And when we press this, this gets called sign up, and we're navigating to the sign up page this way. So now let's create the logic for logging in. So how you do that in Firebase is simply auth, and the method is straightforward as the thing that you want to do. What do you want to do? You want to sign someone in, so sign in with email and password. It's as simple as that. You pass to it the email and password that you want to sign in with. In this case, I have these values over here. So email, password, stored in this variable, user info, which is an object which has the user key, which corresponds to the email, and the pass key, which corresponds to the password. So you pass these over here. So user info dot user info dot pass, and this returns a value, and again it's asynchronous, so you do dot then, and you get here a user object if you're signed in successfully. So I mean, it's not assured that you'll always be signed in. For example, in case the account doesn't exist, the email doesn't exist, the password is wrong. So in case you actually get signed in, this gets called with this user object that corresponds to the user that you signed in as. So here we know that we've actually signed in. So what we'd want to do simply is just navigate to the main page. So navigate to main. But of course, as I just said, it's not assured that you'll always be signed in. So what you do for that case, you'll get an error. And how do you deal with errors? You say .catch, and this is error, the error object. And this error object that's given to you comes with a key called message, which describes what is the error. So it would be nice, for example, to let the user know why he didn't get signed in, so we could alert it to him, show him a pop-up. So how you do pop-ups, as I explained in the last workshop, is alert, and you pass in what you want to show. In this case, as I said, error.message. And that's it. Your login logic is simply 1, 2, 3, 4, 6 lines of code. So just 6 lines of code, you have a login system built for your application, which wasn't that easy before Firebase. So now if we do login again, you see the email address is badly formatted. So it even detects if something's an email or not. Let's say it looks like an email at gmail.com, login. There is no user record corresponding to this identifier. The user may have ... so the error is longer. So Firebase does that all for you. So now I just still need about 5 minutes. So I'll show you how you deal with signup. So let's go to our signup page. Where is it? This is it. So before, when we were signing up, when we were pressing this, it would just give us an alert, signed up. This is the way we were doing it. Now let's actually add a user to our database, to our authentication system. So again, import FB from the file, and you get the authentication object that you use, or the authentication API that you use to deal with authentication in your application. So FB dot simply dot auth, as simple as that. Now, in signing up, what you want to do is auth dot. Before we used sign in to sign someone up, now we want to sign someone in. Now we want to sign someone up. So what we do is exactly as straightforward as the name implies. Create user with email and password. So you pass to it again the email that you want to create an account for, and the password. Userinfo.pass. Again, it takes a dot then, since it's asynchronous with the user object that you get back. In this case, it's the newly created user. Here we know that we actually signed up. So it's kind of like we're signed in. So why go back to the sign-in page and sign in again with that account? Just simply navigate. So navigate to the main page. But of course, even signing up can result in errors. So if we want to deal with those errors, for example, if the user is already taken, if the connection was bad or something, so .catch, it's a function, you pass with a function that takes as input one argument, which is the error object. In this case, let's alert it again. So alert the error message. And just like that, our app is ready. It has authentication, it has database. So let's test it out. So sign up, for example, just press sign up. The email address is badly formatted. I mean, it's basically nothing. Let's say we want to create an account. So Stephen Khaldi at gmail.com. Password like 12345. Sign up. Password should be at least 6 characters. So even Firebase deals with all that logic for you. So you don't have to implement it yourself. So these are like more, this just shows you how Firebase is really powerful. So let's say it's at 6 characters, so 6, sign up. And now we actually got signed in. And now we have that account over here in our authentication system. You see, it automatically gets added. Stephen Khaldi at gmail.com. A user ID gets created for it. So you can use it, for example, in your database. You could have like keys with that ID, which would have like my details. But of course, you won't see the password, I mean. So now let's try to sign in with that account to see what errors you can get and how Firebase deals with them for you. So now we have that account, Stephen Khaldi at gmail.com. So here this is like a wrong password. So if you try to log in, it tells you the password is invalid or the user does not have a password. So Firebase knows that the user exists, but the password isn't right. If we actually write in the correct password, so 123456, log in, it actually works and Firebase logs you in, or the application, I mean, since Firebase gives you the go mark. And the last error I'd like to showcase, let's say you try to create a new user with an account or an email that already exists, so at gmail.com, password, anything, sign up. The email address is already in use by another account. So that, in other words, is Firebase. Or this is like just something, a small part of what you can do with Firebase. So you can already sense how Firebase can be really useful. And that's it for today. So thank you everyone for joining.